Hi, Chris Good here, and we're going to get to the next practice t-test problem. This one's number 4. What does it say? The newspapers have made your depression/sugar studies famous, but you're interested in exploring it further. You randomly assign patients to 2 treatment groups, and neither you nor they whether they're receiving sugar water or plain water intravenously. Oh dear. Well, consider the following data, how depressed they are. So let's just start by assuming that a bigger score means they're more depressed. And here's people who got sugar, here's people with no sugar. Do the data show there's a significant effect of sugar? And that's not the whole question. I mean, it is, what if there is one, what is the effect of sugar? Let's do all the steps in hypothesis testing. So state that null. HO is mu1 minus mu2 equals 0. All right. And step 2 is using, guess what alpha we're going to use? Well, I'm going to use an alpha of 0.05, and we're going to do two-tailed test. So t-crit with how many degrees of freedom? Well, I already had Google Sheets count the number of scores. We have 7 scores. -1 is 6 degrees of freedom, but that's it for each treatment. And so we get a pooled degrees of freedom of 12, and that means we can go to the table and look up our two-tailed critical values. So 12 degrees of freedom. Oh, look, it's the same as the last problem. 0.05 and 2 tails combined, 2.179. So it's going to be plus or minus 2.179, and that means we can now calculate t. All right. Well, you know the drill by now. To get t, we need the mean difference. We have that. This is going to be 0 from the null. The bottom part here, as estimated standard error, we need pooled variance then. Pooled variance means we need sums of squares. And I said last time I could do sums of squares all in one formula, right? But I'm going to use this alternative sums of squares equation, which means I'm going to need sum of x, but I'm going to do that in the formula, in the one formula, and I also need sum of x squared. So I actually need to count. I need to do the squared scores over here, right, and here as well. So that's just going to be this squared. So if you're doing it the way that seemed easier before, right? You need deviations and deviations squared, 2 new columns. I'm just going to do this with 1 column. All right. How do we translate this formula into one line of Excel? Well, it's going to be equal to, right? And I'm going to put this in parentheses. Well, actually, no, not yet. I'm going to say it's the sum of the squared scores. All right. That's the first part. Minus, and then I have to do the double parentheses here. First, I want to sum, and I need more parentheses. I want to sum the scores, right? And then I want to raise that to the second power. All right. And I got a lot of parentheses here, but I had put some. Actually, do I need these inside here? I don't think so. There we go. Let's do this. If I divide that by n, right, which is n for this group, what is this going to do? The first thing it's going to do is what is in parentheses. So it's going to sum the scores and square them, right? And then it's going to do division. It's going to divide by n. And then it's going to do this subtraction. Subtract this other sum, the second sum from the first one. So if we hit return, I'm just going to leave that up just a little while longer. Sum C3 to C9 is the sum of the squared scores. That's this part. And then we subtract first this summed, then this squared, then divide it by 10. All right, so it's going to do this parentheses and then the exponent, and then divide by b10. We get 112 and some change. Let's round that to 2 decimals there. And I've actually already computed sum of squares in the same problem using the other way, right? Oh, I haven't yet, but I can. Sum of squares 1. This is the sum of the squared deviations over here. And we should get exactly the same thing. 112.86 and 112.86. All right. This is actually the same out to many, many decimals. So it doesn't matter which way you do it. And here I've got it all in one line. Let's try that formula one more time. So it's equal to the sum of the squared scores minus the sum of the scores raised to the second power divided by n, the number of scores. So that's our next sum of squares. And let's just double check it. All right. If we just sum up those squared deviations, see, I already had this ready on another page. Yep, it works out exactly the same. So you had to do 2 extra columns here, but only 1 extra column here. It doesn't matter, whichever you're most comfortable with, but you should be able to figure out how to do both. It's time to calculate the pooled variance. That's equal to the sum of the sum of squares, this one plus this one, right, divided by the sum of the degrees of freedom. That's this one plus this one. Now we can do the estimated standard error. That's the square root of this over n1. Gotta do a parenthesis, plus the same quantity over n2. And now we can do t. T is just the difference between our two sample means, mean 1 minus, oops, let's undo that. I forgot to say, hey Google Docs. Hey Google Docs. Mean 1 minus mean 2, and then we just divide it by the estimated standard error, the difference. Okay. Let's round these. Google Sheets still knows what the other digits are. Let's align our labels. And let's decide what to do. What do we decide? Well, if our critical value was plus and minus 2.179, that means 0's in the middle, negative 2.179, positive 2.179 is here, and our observed t was 2.35, that's greater than positive 2.179, which means we reject the null. We really wouldn't write in a paper that we rejected the null, but we would write a sentence like this. Sugar, or let's go back to our question. What was it? Okay. Intravenous sugar water significantly increases depression scores when compared with plain water. And we had 12 degrees of freedom pooled, and our value is 2.35. And the p-value that's associated with that, we don't know what it was, but we do know that it's less than what our alpha was. And that's it.